In the next problem, we have a conical water tank with vertex down that has a radius of 10 feet at the top and is 24 feet high. And so we have something that looks like this. It has a radius of 10 feet at the top and has a height of 24 feet. Now we want to be careful in this not to call the 10 feet radius, or our variable r, and not to call the 24 feet our height h, because as the water is, in this case the water is flowing into the tank, and as the water flows into the tank we can see that the water level is rising. And as the water level rises, both the height of the water in the cup and the radius of the surface of the water are changing. And those are what we're going to refer to as H and T. Sorry, H and R. So we have the diagram here, and we want to find a formula that's going to, let's first talk about the types of rates that we have available here. The water is flowing into the tank at a rate of 20 feet cubed per minute, and that's going to be a dV dt. And we're trying to find out how fast the depth of the water is increasing when the water is 16 feet deep. So we're looking for dH dt when h is equal to 16. So we're looking for some kind of formula that's going to relate dV dt with dH dt, and that would be the volume of a cone, which is 1/3 pi r squared h. Now we do have a problem here in that we have two variables, and the pi is not a variable. The 1/3 is a constant as well, but r and h are both variables that are changing with respect to time. And so we're going to need to use the information to swap out one of our variables, either r or h. And since we are looking for the rate of change of height with respect to time, we need to keep h and swap out r. And from the diagram we could use similar triangles to show that 10 is to 24 as r is to h. Solving for r and simplifying, we would get that r is equal to 5h over 12. Again, why are we solving for r and not h? Because the problem is asking us for h, dH dt. So we need h in the problem. We don't have any information about r, so we want to swap out r. I hope that's clear. So swapping out r for h, we're going to get 1/3 pi quantity 5h over 12 squared times h, and that should give us something like 1/3 pi 25 over 144 h cubed, which we can then differentiate with respect to time. And dV dt then is 3, which comes from bringing the exponent of h cubed down, times 1/3 pi 25 over 144 h squared. And we can see that the 3 and the 1/3 cancel out, and we get 25 pi over 144 h squared. Now we're told that h is equal to 16 in the problem. That's the only unknown here. So and 16 squared is 256, and that gives us 256 over 144 boils down to 16 over 9 times 25 pi, and I believe that gives us something like 400 pi over 9 cubic feet per minute. Again, I'm rushing through that, so I hope that I haven't made a mistake in there. If I have, you see it easier than I do. I'm trying to get this out before it gets too late. So, but the basic way of solving the problem is there, and hopefully that will help you to solve that problem as well.